In this tutorial, I will show you a not a really common package or libraries in when using Python, but it may be useful for you if you are searching some libraries helping you for some mathematics expression like calculus or like some trigonometry, cosine, tangent, sine, something like that. Okay, first of all, I will create a new project in the PyCharm. If you don't know how to do that, you can just take a look of my other tutorials. I already showed how to create a new project, and also as a starter, how to create some code. And most importantly, in this tutorial, I will show you how to install. Just go to the terminal, okay, and at the bottom, just type pip install SYMPY, which is the name of the libraries. It just usually take like 10 seconds or more for the installation, and you will see that some extra package like the math and other things else will be installed. Okay, yeah, now finish, and then I just clear the command, and we can start how to use these SYMPY libraries. Okay, yeah, you can even use another way to install the package. Like in the preference, we have the add package, but I don't want to waste time to show you in this tutorial because I already showed in another tutorials. So I just focus how to use the SYMPY, some basics operation, or how to just print some cosine and tangent in our program. Alright, so first of all, in the first line of the code, just write SYMPY import, and then some you may be familiar like the sine, cosine, tangent, and also symbol. Okay, you will know if you didn't import those math function, you can't use it, and you will get an error. Okay, so just keep on reading, watching this tutorial, and then you will know that. And from sympy.abc import x. Because when we are doing some trigonometry function, we will have some substitute variable into the function, like tangent x multiplied by cosine x. Okay, so if you have some background of this kind of mathematics, you will know what I'm going to do. But if you don't know, you can just Google and find it out, and I guess you will know what is going to happen. Okay, so I'm just trying to print the results. Okay, and then now you see it print out cosine x multiplied by tangent. And maybe you will ask, okay, it's just like some normal printing, right? But I hope you can observe that we are not printing a string. Instead, we are printing a symbolic expression. Okay, for example, now I just add multiply sine x, and then I just run the program again, and then you will see the symbolic expression sine x multiplied by cosine x and multiplied by tangent x. Alright, it is not a string, that is a symbolic expression, remember that. And I try to multiply cotangent x and run, we will get an error. Okay, yeah, because cotangent is not defined yet, so it proves that this is not really a string. It is something which is much more interesting. So I need to import the cotangent in our first line of code, and now after we run the code, it will run out the symbolic expression. Okay, alright, so now I try to change the variable x to variable y and run the program. You will get error again because the variable y is not import as the substitution variable. So we need to import the y, and now when we run the program again, the program can recognize the x and y variable because we have did the import in our program. All right. So again, we try to import set, and now you can see the program can recognize x, y, and z, and the result will be the symbolic expression. Alright, so I hope you understand what I'm doing. Even though I can change the variable to 30 degree, if you have learned what is cosine, sine, and tangent, cotangent, and then you should understand what I am doing right now. So in case you are trying to do some project, want to showing some expression like calculus, integration, differentiation, SymPy package is definitely a good choice for you to showing some really complicated mathematical symbolic expression. Okay, so I just try to change more variable and also the and the expression so that you can understand a little bit more about what it can do and what it cannot do. Okay, so next I will show you something a little bit more about the SymPy, that is a integrals. Okay, integrals. If you have learned something in trigonometry and what is integrals, you know what I'm going to do. I try to import a function. I can call it a function, a trigo integrate. All right, so this is a short form of the function. Okay, I guess that is a integral trigonometry short form function, and we can just put something like cosine x and also sine x. Just put inside this function, and let's see what is going to happen. If you have some mathematical background, if I'm going to write cosine x divided by sine x, what is going to happen? Now, you will see, okay, I missed something. I missed an argument because in this function, we need to have some argument like what is the variable. So just put x inside the function and then you will see what is going to happen. Okay, everything ready and run the program again. Okay, so I missed another thing I need to print it out. So I define a variable called result2, and okay, I just print out the results2, and let's see what is going to happen in this program. Okay, so I just run, and it's so log sine x. And why cosine x over sine x will equal to log sine x? This is a mathematical problem. Okay, you can check with Google how it is going to work, because in this example, I'm not really going to explain too much about some math knowledge. But you can just Google and find some table and how this sine over cosine using the trigonometry integrals, how it's work. You will know that actually it's just something related to mathematics. But in this example, you can see what I'm going to show you is SymPy is a really powerful library or package in the Python, helping us to do a lot of work trying to make the the math symbolic expression more efficient. And you will know that in my other tutorials, I will show you more related to calculus, differentiation, how to do like the square root, how to just print the square root out or the log. A lot of things we can do with these SymPy libraries.